our final, but by no means least, presentation. This is by Sriteja Kataru. He is a high schooler at the upper school at Harker, and he will be speaking about his work analyzing mental health data. So welcome, Sriteja. I'm going to stop sharing. I'm going to make you the host. Perfect.
Hi, everyone. My name is Sriteja, and I go to the Harker Upper School. So let's start with my presentation, Analyzing Mental Health Data with Machine Learning. So let's go over what I'm going to go over in today's presentation. So first, I'm going to go over the problem. Why is mental health such a big issue today? And then I'll be going over the data, so the information to supply the basis of our machine learning model. After that, I'll analyze the data to know what all this information means. And then I'll be going over the steps for my AI model, which is creation, training, and development. After that, I'll be talking about my results and outcomes and insights. So first, let's start with the problem. The importance of mental health. Mental health problems impose a serious health burden on kids and teenagers, yet they largely remain neglected. They're not talked about, not given importance, and not addressed. Only now we are starting to see a difference in schools and mental health, but still it needs to be more of a bigger thing. Conditions such as stress, depression, and anxiety disorders are widespread and growing. But why? This modern lifestyle with including remote schools, social media, all of these things are placing increased demands on kids and teenagers. And did you know that the onset of approximately half of all adult mental health disorders occurs before the age of 14? And it is estimated that 20% of children aged 9 to 17 have a diagnosable mental health condition that impairs their ability to function. Next, let's go over the data. So the data I have is an anonymous record of a mental health screening from Healthier Kids Foundation, a nonprofit organization that strives for the benefit of the health of the youth. HKF did a mental health screening online where they asked a series of questions related to the emotions of the kids that they're interviewing in order to analyze their overall mental health status. So yeah, this is a private data set, which I forgot to mention in my slideshow, but I work with this organization, so they gave me this data set. So let's go over the questions. The questions asked in the interview talked about the emotions that the kids felt in the past week. So for example, one of the questions that they asked was, I felt sad. And the kids had to answer that on a scale of 0, which is strongly disagree, I've never felt sad in this past week, to 4, which is strongly agree, I've felt sad a lot of times this week. All the answers will then combine into one final numerical score. And as for numbers, there were 375 kids interviewed, 13 questions asked, and 2 open-ended questions, which were notes from the doctor and also a follow-up category, which is evaluated by A, the total score, and B, the doctor's overall notes of how they think the interview went. So let's go over the data analysis. What does all this information mean, and how can we use this for our benefit? So here's some important terms to know before I go over my first chart. So the average is the mean value of all the numbers, and standard deviation is a measurement of a collection of the values dispersion. A low standard deviation shows that the values are close to the set's mean, whereas a high standard deviation suggests that the values are dispersed over a larger range. So here's the chart of all the questions asked, and the second column is the average values, and the third column is the standard deviation. So let's talk about the key takeaways from this chart. After we calculated the average, minimum, maximum, and standard deviation for every question, we found out that there has always been an answer of 0 and 4, suggesting that this data has a wide spectrum of results. The highest average value for a question was MHFQ9, which was I felt nervous, with the average being around 1.1. The highest standard deviation for a question was MHFQ11, which was I felt mad, with a value of 1.15, around that value. So next, let's go over Pearson correlation. But what even is a Pearson correlation? It's used to measure how strong a relationship is between 2 variables. And why are we looking at these correlations in my case? Instead of looking at each of the questions by themselves, we can look at the questions relative to the other ones. So if a person answered a question this way, how likely are they to answer the question, another question, like the same way? And it's denoted by 0, which is least correlated, or 1 or -1, which is most correlated. I'm not using -1 because that means that if one goes up, the other one goes down. And all my questions are talking about like feeling sad, mad, so negative emotions. So there's no -1. So here's the chart. We can see that there's a bunch of values ranging from 0.3 to 0.6. And then we see the diagonal values, which are the same, of 1. But why is this? So let's go over the key takeaways from this chart. Questions like I was angry and I was upset were highly correlated for obvious reasons. Diagonal comparisons, as we saw in this chart, it's a value of 1 because it's comparing the question to itself, so it'll always be the same. Another piece of data that we were given was that each person was given a priority star. But what even is a priority star? It's an assessment of risk that the evaluators give after they do the interview. So they give, after they answer all the questions, the evaluators give them either 1 star, which means that no follow-up is needed, or like 2.5, 2 or 3 stars, which means that this person needs a follow-up. These stars are not entirely dependent on the total score. So some people with a high score have a low amount of stars, and some people with low scores have a high amount of stars. This is because this is entirely human judgment, which might be a problem in the future. Another piece of data we were given are the text columns. The text columns were notes or questions from the evaluator, and the 2 text columns that we were given were what is one way to help an upset friend just to gain some information from that person, and the pediatrician's overall notes of the person, of the interview, and how everything went. So using priority stars, how can we use these priority stars in an AI model? At first, I thought of using the text boxes to predict the priority stars, but then after doing some experiments, I realized that that doesn't work because most of the notes, they don't allude to anything significant. Then I wondered if I could merge the notes from the evaluator and the individual scores from a person, the AI program could predict the priority stars. But then I hit a roadblock, which are stop words. To work with text, we have to remove stop words, but what even are they? They're words that are not significant and removable, like a, the, his, her, etc. Removing these words could enhance the program by making the text columns more clean. And along with stop words, we have to remove columns with no text. Otherwise, the model will be confused and then produce an error. So here we see a before and after with stop words and without stop words. So here we see she is very mature for her age. And then after I input it into the Python program, which removes stop words, the output is she mature age, the only relevant words in the text. So then let's go over AI models. So experiments that did not really work. So first I used only the scores from each question to predict the priority stars. And even though the accuracy was really high, it's not really a significant thing to predict just based off the scores. And then I used the total score to predict the same thing. But then again, it wasn't really significant because the AI model thinks that if the score is above a certain number, then it gets a certain rating, which isn't necessarily true. And then I also made AI models on each of the text columns separately to predict the total score, but that did not yield me any good results. As you see, as the RMSE is a high number, which basically states the error. And then I decided to merge the evaluator notes and the numerical scores together to predict how many priority stars that person is likely to give. And that seemed to work pretty well, which leads me into my final experiment. With the individual scores and the cleaned up text, I inputted the data into Navigator, an artificial intelligence service that uses the Amazon cloud, and Navigator invokes scikit-learn, which is a machine learning library. When I trained the data, I used an algorithm called random forest, which is a specific type of algorithm that deals with AI models like mine. I used different algorithms with different experiments, but random forest seemed to work best. And then let's go over the results. So some important terms to know is confusion matrix. A confusion matrix is a special table layout that allows for the visualization of the performance of an algorithm. This is how we know if our algorithm is working well in all areas of our data. So here we see that the predicted values of 1 star are 37, and that was actually a true value. So we know that our algorithm is good at predicting 1 stars. But then we see 2.5 stars, there's nothing. That's because the data didn't really provide that much of a 2.5 star data. So then the accuracy came out to about 87%, which is pretty good for an unpredictable like kind of scenario like mine. And then feature importance. This ranks the influence that each question or factor gives into the prediction. And words from the text columns did have a feature importance, but it has an extremely small value. And these feature importances are like kind of random at times. So here are some insights after doing this project. This AI model could be an assessment of risk. So if I create an app or website, the next time that these people do an interview, they can use my model to help them. But it's important to recall that this is just a tool to help with human judgment. It doesn't replace the human evaluator's decision. And this could lead to more consistency within the ratings as well. Evaluators can use this to cross-check their decisions. And at the end, I learned that you can't use the raw data just as it is. You have to tune it and analyze it to put it into your AI model and get a good AI model. And with that being said, thank you. I will answer any questions that appear.
Thank you very much, Sriteja. So the first, you can make me host. The first question is, do you think that the algorithms that you've used in your project would be applicable for adults? How might you find that out?
Yeah, I think this could definitely be applied to adults, but the only problem is I'm using data that only deals with children. So I'd have to find another data set that was more accurate towards adults and that kind of age group.
Sure. And makes sense. And then, so let me just make that a note. And then for RMSE, what do you think would be a good number?
Definitely not the numbers I got in my experiment. So it should be like less than like, let's say like 2 or 3. That's what I would think. It's a pretty decent RMSE, but still it could depend.
Yeah, and then it's relative. So I think the maximum, if I remember right, the maximum value you could have gotten was like 40, right? Or
Yeah.
actually, so because of that, the 6 or the 7 wasn't very good. Yeah, makes sense. And then since you are describing both RMSE and accuracy, could you elaborate a little bit because of why those two different algorithms were different? Because one was trying to estimate the score, I think, and the other was trying to estimate the star category.
Yeah, so I used RMSE to basically calculate the average for the text columns because if a text column isn't accurate, it just gives 0%. It doesn't like it doesn't state like whether it's close enough, it's either right or wrong. That's why accuracy isn't a good measure for text columns or any other data stuff like that. So I used RMSE, which basically states like how the amount of error that the model produced. And then since I used numerical values, accuracy is pretty good for determining the error for numerical values. And that's what seemed to work in my model.
Okay. And then the final question was, how did you come up with the list of questions? Since you're working with an organization, I assume they did. Do you want to provide any insight into how they came up with the list of questions?
So I don't really know how they came up with the questions, but they gave me the data to work with. And yeah, that's pretty much it.
Sounds good. Thank you so much, Sriteja. Thank you. Very nice presentation.